Hi everyone. In this video, we're going to talk about acetone. My name is Nur Alahanim binti Muhammad Zaki. My student ID is 2023460852. And this is my group member.
Acetone, acetone, also known by its Arabic name propane-2-on, is the simplest and most commonly used ketone. It has the chemical formula C3H6O and appears as a colorless volatile liquid with a sweet pure odor. Acetone is completely miscible with water and many organic solvents, making it a powerful and versatile solvent. It has a low boiling point of about 56 darjah degrees Celsius, which allow it to evaporate quickly. Acetone is commonly used in laboratories and industry for cleaning, extracting, and dissolving substances, and it also main ingredient in nail polishing removal. Acetone has a simple and symmetrical structure consisting of three carbon atoms, six hydrogen atoms, and one oxygen atom, with the chemical formula C3H6NO. It is ketone, meaning it contains carbonyl group, a carbon double that bonded to an oxygen, position in between two metal groups CH3, giving it the structure CH3COOH carbon. The carbon group is sp2, hybridized making the molecule flat around that region, and the polar nature of carbonyl group makes acetone a polar molecule. This polarity allows acetone to dissolve both polar and non-polar substance, which is why it is widely used as solvent in laboratory and industry. The functional group present in acetone is carbonyl group C-O, which is characteristic of ketones. In acetone, the carbonyl group is bonded to two methyl group CH3, making it simplest ketone. This functional group is responsible for many of acetone's chemical properties, such as polarity and ability to act as solvent. The carbon the carbonyl group also make acetone reactive in organic reaction like nucleophilic addition, making it important in both industrial process and laboratory chemistry.
Characteristic of the homology series of acetone, which is ketones. First, functional group. Carbonyl group, which is C-O, located between two alkyl groups. Second is general formula, which is CnH2NO for straight chain ketones with one carbonyl group. Third is successive members. Each member differs by CH2 unit. Fourth is chemical properties, similar reactivity due to the presence of the carbonyl group. For example, is methanol, formerly HCOCH3, not stable, so acetone is often considered the first stable ketone. Next is propanol, acetone, CH3COCH3. And the next one is protanol, methyl ethyl ketone, CH3COCH2CH3. And the last one is pentanol, CH3COCH2 2CH3 or CH3CH2COCH2CH3 depending on the isomer. These ketones show a regular gradation in properties such as boiling point and solubility as the carbon chain length increases, but all retain the ketone functional group, which give them similar chemical reactivity. Physical properties for acetone. The first one is molecular formula C3H6O. Next is molecular weight 58.08 gmol. And the next one is melting point negative 94.9 degrees Celsius. Boiling point is 56.08 degrees Celsius. Density is 0.791 gml at 25 degrees Celsius. And the solubility is miscible with water, ethanol, and ether. Vapor pressure is 184 mmHg at 20 degrees Celsius. Flash point is negative 20 degrees Celsius. And the last one is auto-ignition temperature, which is 465 degrees Celsius. Chemical properties for acetone. Reactivity of acetone is highly flammable and reacts with strong oxidizer. pKa 19.3 at 25 degrees Celsius, indicating weak acidity. Partition coefficient log col, which is negative 0.24, meaning it is more soluble in water than in lipids. Explosive limits is 2.6 until 12.8% volume in air. Although odor threshold is detectable at 42 ppm. Uses for acetone is commonly used as a solvent in laboratories, nail polish removal, and industrial application.
Next is benefits and uses of acetone in laboratory uses. First benefits is highly volatile, which acetone evaporates quickly, leaving minimal residue. Secondly, effective solvent. Acetone dissolves a wide range of organic compounds, including oils, greases, and resins. Third, miscible with water. Acetone mixes easily with water and other solvents. Fourth, cost effective. Acetone is relatively inexpensive and widely available. Lastly, for the benefits is low toxicity compared to other solvents, which is safer to handle under proper ventilation. Next is uses of acetone in laboratory uses. First is glassware cleaning. Acetone is often used to clean glassware due to its ability to dissolve residues and evaporates quickly. Secondly, sample preparation. Acetone used to dissolve or dilute samples in chromatography and spectroscopy. Third, drying agent. Acetone helps remove water from wet equipment or samples due to its miscibility and fast evaporation. Fourth, recrystallization. Acetone used as a solvent or anti-solvent in purification of compounds by recrystallization. Fifth, degreasing agent. Acetone is effective at removing grease or oily substances from equipment. Next, polymer and plastic work. Acetone used to dissolve or soften plastics and polymer in research or sample preparation. Seventh, surface preparation. Acetone cleans and preps surfaces before coating or analytical procedures. Lastly, as a reaction medium, acetone also used as a solvent in some organic reaction, although it is limited by its reactivity and volatility.
Next is benefit and uses in medical and cosmetic application. Now let's start with the benefit first. First one, acetone is a powerful solvent, which means it can dissolve many substances easily. This makes really useful for cleaning, mixing, or preparing surface. Next is non-staining, so it evaporates without leaving any mark or residue. Speaking of evaporation, that another great feature acetone evaporate quickly, which is especially helpful in both medical and cosmetic setting where drying time matters. It also cost effective because it's affordable, easy to find, and widely used around the world. And lastly, acetone has antimicrobial properties, meaning it can help reduce bacteria and lower the risk of infection. And next, let's look at how acetone is used in the medical field. Acetone can act as disinfectant and antiseptic because it can help keep germs and keep things clean. Is often used to prepare the skin before injection or surgery, making sure the area is safe and bacteria free. It also can be used for wound cleaning, especially for minor cut or injuries. And in pharmaceutical, acetone works as a solvent to help dissolve certain active ingredient in medicine. And we are moving on to cosmetic uses. We have probably used acetone without even realizing it. One of the most common use is nail polish remover. It quickly breaks down the polish and leave nail clean. It, it also uses a degreasing agent, removing oil and dirt from the skin or cosmetic tool. In some products, acetone works as a mild exfoliant, helping to remove the dead skin cell. And lastly, it's great for cleaning cosmetic tools like brushes and applicator. It's keeping them free of bacteria and product build-up.
Next is benefit and uses of acetone in biological and environmental significance. Firstly is biological benefits. Endogenous production. Acetone is naturally produced in the human body, especially during fat metabolism, as an example during fasting or ketogenic states. Secondly, metabolic indicator. Its level in breath or blood can indicate metabolic condition like ketosis or diabetes. Next is environmental significance benefits. Natural occurrence. Acetone is produced by plants, trees, and microorganisms, making it a naturally occurring compound in the environment. Secondly, biodegradable. It breaks down relatively quickly in the environment through microbial action and photolysis. Next is uses of acetone in biological significance. First one is tissue fixation. Acetone used in histology to preserve and fix tissues for microscopic analysis. Secondly, protein precipitation. Acetone employed to precipitate proteins from biological samples for purification or analysis. Third, DNA or RNA extraction. Acetone occasionally used to remove lipids or contaminants during nucleic acid isolation. Fourth, dehydration agent. Acetone used in preparing biological samples for electron microscopy. Lastly, for uses of biological significance is antibacterial testing. Acetone acts as a solvent for certain antimicrobial agents in microbiology labs. Next is acetone uses in environmental significance. Firstly, environmental monitoring. Acetone used as an indicator for industrial emission or atmospheric studies. Next, volatile organic compound (VOC) studies. Acetone included in research on air pollution and VOC behavior in atmosphere. Third, solvent in environmental analysis. Acetone used to extract and analyze contaminants in soil, water, or air samples. Lastly, wastewater treatment research. Studied for its behavior and breakdown in treatment processes.
Chemical reaction of hydrogenation. Hydrogenation of acetone, which is CH3COCH3. Hydrogenation is a chemical reaction where hydrogen gas H2 is added to a compound. When acetone is hydrogenated, it turns into isopropanol, a type of alcohol. The reaction is CH3COCH3 plus H2 to become CH3CHOCH3. Reactant is acetone. Product is isopropanol. Catalyst is Ni, Pd or Pt, commonly nickel. Condition is heat and pressure may be applied to speed up the reaction. Explanation. The double bond in the carbonyl group, which is COO, is broken and hydrogen atoms are added. One hydrogen added to the carbon and one hydrogen added to the oxygen, resulting in the formation of hydroxyl group, negative OH. This reaction is widely used in the chemical industry to produce isopropanol, which is an important solvent and disinfectant.
The last chemical reaction is aldol condensation. The purpose of this chemical reaction is to form carbon-carbon bond between aldehyde or ketone with a hydrogen. The reaction with acetone is 2CH3COCH3 produce CH3COCH double bond CHCOCH3 plus H2O, and the product is methyl oxide. The general formula base catalyzed is 2R CH2 COR prime produce RCH double bond CHCOR prime plus H2O. So the step is first one acetone form an enolate ion in basic condition. The enolate attack another acetone molecule carbonic carbon, and a beta hydroxyketone intermediate is formed. On heating, water is eliminated and becoming formed in an beta unsaturated ketone. So the significance of this chemical reaction is other condensation is important to CC bond forming reaction in organic synthesis. The conclusion: acetone is an essential compound in both nature and industry. It serves vital metabolic function in living organisms and for utility in chemical, pharmaceutical, cosmetic, and industrial application. Due to its ability to interact with a wide range of substances, acetone remains a fundamental solvent in many scientific and commercial processes. Its chemical reactivity further enhances its importance in organic synthesis. That's all from us. Thank you for watching.